So we're going to be doing a demonstration for half-lives and how to calculate them, and we're going to be using pizza. Usually in my face-to-face classes, I actually bring enough pizza for each of you guys to do this experiment, but we're going to go ahead and do it virtually. So at least one of us can get some good tasty pizza out of the deal. So, as you learned in all the readings in the module, that we use radioactive elements and we measure how much that this radioactive element has decayed into half of what was left and half of a new element. Sorry, I'm stumbling. And so I'm going to kind of give you a visual example of how that works. So let's start with our pizza. And I already wrote some of this stuff in. We're going to be using the radioactive isotope pizzarium. And pizzarium has a half-life of 1,500 years. So what that means is it takes 1,500 years for pizzarium to decay into 50% pizzarium, 50% the new element, dominosium. Then Poppy wants to get in on the action too. Hello, Poppy. So, when you heard the term parent, you heard the term daughter in your modules. Parent means the original element. The daughter is the new element that it's turned into. And so let's go ahead and today, right now with pizza, we have 100%, oh, it's hard to write upside down, 100% of the parent element, isotope, and 0% of daughter. Am I right? And there's been 0 half-lives, and the age is 0, meaning it's the present. So we're going to fast forward 1,500 years. And so what does pizzarium look like after 1,500 years? Well, it's already cut for me, but I'm going to pretend. So we have lost half of pizzarium. Bye-bye. So now, this is the parent side of the box. This is the daughter side of the box. We are left with 50% of the parent, which is pizzarium. Poppy, I love you so much, but I really love my charger set and I don't want you to chew it. So now we're left with what's in this box here. We have, oh, I don't know if I can do this upside down. 50% of the parent. Poppy, 50% now of the daughter, which is the new element that it's made. Okay, Poppy, you cannot have a slice before I get a slice. Down. And then, so that means that if there's 50% of pizzarium, we've had 1 half-life that's occurred. And that gives us an age of 1,500 years. Ooh, I'm doing good upside down, aren't I? Okay, does that make sense, guys? And so, so now we fast forward another 1,500 years. Okay, that would be 3,000 years from modern day. Okay, I'm gonna get really mad at you, Poppy. She's really annoying me right now. Okay, well, we're gonna have to. Okay, so here is the pizzarium that has undergone 1 half-life. Go away, Poppy. So we're gonna go ahead and fast forward another 1,500 years. Okay, so bye-bye. So we're now left with, I'm telling you right now, you need to be quiet, puppy. Okay, so now from the original isotope of pizzarium, what percentage is left here in this part? We have 25% original pizzarium, which means that the daughter, the new element, there must be 75% of, right? And so how many half-lives must have happened in order for there to only be 25% left? 2. This is a hard one. Did I do that right? Is that facing the right way? That's the 2 half-lives have happened, which means that this ratio now is 3,000 years old. Okay? And we're going to do it again. We're going to do it again, and we're going to cut. Well, this is not a very equal cut. The pizza man's going to get in trouble. He's messing with my experiment. So we're going to go ahead and cut it again in half, relatively. Okay? So now this pizzarium that was not originally, but right before I just did that, was 25 to 75%, right? We just cut it again in half. Okay, what does that leave us? 1,500 years gone by. That leaves us with 12.5% pizzarium. Let me go put this over here. Bye-bye. And, oh boy, my math is so bad. 87.5, am I right? Paula, I'm terrible at math. Yes, 87.5% daughter, which is this stuff over here, which is, well, the blank box will be the new isotope element, the daughter product. Does that make sense? And so if there's 12.5% pizzarium left in my, of my isotope left in my rock, then 3 half-lives must, oh geez, this is even worse. Is that correct? Yes. 3 half-lives have occurred, which means that, how old does that make my rock? 4,500 years. For every half-life, right, it ages, it's 1,500 years. It takes 1,500 years to turn it into a 12.5% parent-to-daughter ratio. Can we do it again? Sure, why not? Okay, so we're going to cut this guy right now in half again, which means that now I have 6.25% pizzarium. Let's take this guy. Bye-bye. Okay, which gives me 93.75% daughter ratio. Right? So if I have a rock with only 6.25% pizzarium, then I know that it's undergone 4 half-lives. How old is that rock now? 6,000 years old. Do you see what I'm doing? Every single time I have a half-life, I have to take and cut in half what's left of the parent isotope amount and cut it in half, cut it in half, cut it in half, cut it in half, which increases the daughter ratio, right? Which is that part of the pizza, the part that I keep moving over there. That's how much of it has changed. This is how many half-lives it has undergone. And for every time it has a half-life, it goes up by 1,500 years. And honestly, I can do it again. This is what I'm going to have to get a calculator now. See, we cut it in half again. What does that make it? Oh my gosh, 3.1255. We're going to go ahead and do that. 3.125%, right? Because that's half of 6 1/4, which means that we have a daughter now of 96 point, oh my gosh, 87.5%. And if that's wrong, I'm sorry, I'm just not that fast with basic math. I'm not even have a finger to use. And so if I have 3.125%, here, let me move that over, pizzarium, then I know that my half-life has now undergone 5, which makes the age of my rock 7,500 years old. Now, can I keep doing this? How far can I keep doing this for? There is an end. All elements, all isotopic elements, all radioactive elements do have an end, a finite point where you cut it in enough half. I can keep cutting this in half, cutting this in half, cutting this in half. Even to the point where I'm at the atomic level, right? I need a microscope to cut it in half. There will reach a point where it becomes finite, and then there's no more parent isotope left, and it's all daughter. But in that time frame, unfortunately, we don't have the technology to only measure the percentage of parent isotopes and age date that way. We have to take the ratio between the parent and the daughter and the radioactive decay, and we use half-life. We can't measure it in the whole, we have to measure it in halves. And so this is actually a really useful tool, and you can get absolute age dates in numbers of years by using radioactive elements that you can measure the half-lives of. So that's it for now.